的方式给大家带来全程的讲解。那今天非常荣幸呢，我们中科院呢也是派出了4位专家哈，给我们带来全程的实时讲解。
And we have invited 4 experts to give us the secrets about such a nature's code. Now please follow me into this key laboratory. Professor Zhang is waiting for us. For your information, this is a researcher from the key laboratory, Mr. Zhang Qiang. Dear viewers, good afternoon. I am Zhang Qianggong from the key laboratory. I major in the climate change in Tibetan, and I mainly study the glaciers. Welcome to our laboratory, and you could see that in front of me, this is a small refrigerator. In it, there are some samples of the ice cores. I'm gonna promote the ice cores from Tibet today. They're colorful. This one is in yellow, and this one is in white. It's after all summer days. In such a heat wave, we want to bring some coolness to our viewers. This really looks like the ice suckers. But as to the ice cores, do they have such a stick in it, a wooden stick, just like the ice sucker? We will give you the answers in the key laboratory. Let's learn something about ice core first. Let's firstly learn something about the glaciers, and we will enjoy the taste of the ice suckers later on. Today's live show aims at transmitting knowledge. Even though we want to promote such delicious ice, we are not charging our viewers, as long as you could learn some knowledge about the ice cores, the glaciers, and the Tibet. Now let's look at this map. As you know, the globe is covered with ice, and we can see the blue lines circling the glaciers, and the majority of the ice caps are in the North Pole and South Pole. And as you know, in the low latitude areas, Tibet is one of the most highly covered ice regions. And the total area of the glaciers is about 50,000 square kilometers. Hainan Island is as large as 30,000 square kilometers. So in China, the glaciers cover about 2 times the area of the Hainan Island. You could imagine how big is that. And what does the glacier looks like? This is one photo. As the saying goes, the thick ice caps are not formed within one day. So they're not frozen in one night or one day. There will be snowfalls on top of the mountain, and day after day, the melting of the ice caps form the glaciers. And on the top surface is ice, and below that ice cap, it's mainly the snow. And in this photo, we could see the photo looks like the tree rings. And if you look from another angle, it looks similar to pages of a book. It's like the wordless scripture of the nature. And for that page-like in that ice cap, they are formed year after year. We call it annual layer. If we want to get some ice from the Tibetan plateau, it's not easy work. The higher we climb, the lower the temperature will be. And there will be a lot of layers of snowfalls year after year. And below that layer, there will be some snow melted, flowing to the foothill. And we will have to go to the high latitude and use some drills to get the ice, and this is the equipment we use to get the ice from Tibet. On top of the glacier, we built such a tent. We have to work in the tent for a long time, and we carry the drills into the camp, and this is how the drill looks like. This photo is how we drill into the ice cap within this camp. We keep drilling until we could touch the ice core and lift it up. This is the head of our lab, Mr. Yang, and that is Thompson. Those two have been drilling in Glacier at about over 6,000 meters above sea level. For that ice core, it's about 1 meter. We have limited technologies in the drills, so we have to use 1 meter as a unit when we drill downward. Can you imagine how long is the ice core in total if 1 unit of the drill is about 1 meter? I myself have been wondering that everyone could eat some ice suckers, and this ice core from the glacier looks quite clean. Can we directly taste the ice core? I think the water is very clean in the snow mountains, so I think it's something to enjoy in summer. And there is no additives to it because it's from nature. Have you tasted ice cores? Actually, we did when we were drilling. And that ice sucker is about 1,000 years old. It looks like chocolate. If we keep drilling, where would we get? We will get to the bedrock. You could see some rocks in the ice cores. If you look at this color, it means we have already drilled to the bottom of the glacier, and we have gotten all of the secrets of the scripture out. Then we store the ice cores. In Lhasa, there is one very big ice house. Many precious ice cores directly gotten from Tibet have been stored in that ice house. After 20 to 30 years of efforts, scientists have been working in about 10 sites in Tibet, and a lot of ice cores have been distilled from the Tibetan land. And from those ice cores, we could learn the changes of Tibet. We could measure the rainfalls, the temperature, and we could listen to the weather forecast. But for the ice cores, they have been left thousands of years ago, even tens of thousands of years ago. So from those ice cores, we could learn more information. I know you must be eager to know the answer of the length of ice core. I'm very proud to give you the answer. In China, the length of the ice core in Tibet is the largest. It's about 309 meters long. It's the longest one in the world. If 3 meters make 1 story, then 309 meters means we're standing in a 100-storied building. You could imagine how long is that ice core, and you could further conclude how much information can we get from that nature's book. This is a processing room for ice cores. The majority of the ice cores have been on the way, so we could only have a glimpse of this processing room. Now the temperature inside is about 20 Celsius degree below zero. This is far from enough if this room is on the work. We usually have to cut these ice cores into smaller slices. It's like you're tearing apart this wordless book, page by page. We cut off the out layer because the out layer has touched the drills, and we don't want it to pollute the cores. And then we store them in the refrigerator. So what can we read from this scripture and this book? The ice sucker tastes good, but as you know, there are different flavors of ice suckers. The milk flavored or chocolate flavored, that's the difference. It's the same thing with the nature's book. There are different information. Now let's enter into the laboratory. All of those equipment you can see will be the helper for analysis. One thing I want to introduce to you is about the gases from the core. CO2 is contained in like a Coca-Cola, so we can get some gases from the ice cores as well. And our senior engineer, Mr. Li, will introduce to us what can we get from the ice cores. Good afternoon, Professor Li. Good afternoon, dear viewers. I am Li Jiule from this key lab, and my job is about the gases study. Like Professor Zhang said, in the ice cores, there contain a lot of different materials and gases. We welcome you to learn more about the secrets of ice cores. But what about the gases of ice cores? Why is it the subject of our study? Now let's look at this photo for more information. In the nature, as we know, the snowfalls pile one layer after another to form ice caps. When the snowfalls touch the land, there are a lot of pores between those snowfalls. But gradually, with the snowfalls, land on the surface, in the bottom layer, the density becomes higher and they form ice. But for the upper layers, the room between different snowfalls may form gases. That's what we call the bubbles of ice cores. So that's actually air that haven't escaped the snowfalls. It's one way for us to learn something about climate change and the air in ancient times. From this photo, taken in our laboratory, we could see clearly the layout of those gases and the bubbles in the ice cores. This is one slice of ice core, and the white dots are actually the bubbles in the ice cores. From this thermal bottle, this is one sample of ice core. And this ice core was taken from a height at 5,600 meters. And it's about 700 years old. This ice core from Tangola Mountain is very ancient, and within this ice core, the bubbles have been formed about 700 years ago or even longer. And the composition of that bubble is the same thing as the 5 different compositions in the air. So let's take a closer look. And we can compare that ice core with the ice sucker. You could see how beautiful is this ice core. There are some bubbles in it, but as to the ice sucker, there is no such bubble. We cut the ice core into such different ice cubes and we put them into this instrument. We make them into vacuum air. And by heating, we melt the ice core. Then the bubbles and the air inside the ice core will be given out. Since this instrument has a very good heat conduction functionality, so the low temperature will be transmitted into the middle part of the instrument, and the melted water in the middle will be further cooled down, and then the air in the ice cores will be given out. This one is a climatic chromatography. We could further analyze the composition of atmosphere. For example, we use this instrument to study the composition of oxygen and CO2 composition. So from the different ice cores formed in different times, we could analyze the information, and then we can conclude the climate change. This graph is from our laboratory. Our scientists made this graph, and the blue line represents the changes of methane in the atmosphere over the years. In the beginning, we got one ice core from about 700 meters high. So in the horizontal line, that's about the years. In about 1850 and before, there was very slight changes of the methane, but ever since 1850 until recent years, you could see a sharp increase of methane in atmosphere of ice core. That implies that the greenhouse gases have been emitted into the air ever since the Industrial Revolution. It's also in line with the climate change and global warming. So our study proves the point. We do hope that in the future, our viewers could pay more attention to environment protection. Let's protect this globe together. It's crystal clear that ever since the mid-19th century until the 21st century, there was a sharp increase in the content of methane that commensurates with the higher human activity ever since the Industrial Revolution. Without this graph, we cannot get such obvious conclusion, but the data and the graph are there in front of us, and we have to act upon those proofs. We have to conform to low-carbon principle and protect the environment, and then our air will be cleaner. Thank you for your introduction. That was an interesting story. As Professor Li said, that ice core was gotten from Dasopu. And this photo was the photo about that incident. You could see the tent and the mountain as the background. In 1997, Chinese scientists have been working in Himalaya, and the height is about 7,200 meters. That's the highest point to distill ice core in the world. So in China, we have the longest ice core and the highest ice core. China is a leading country in the technology of drilling ice core. Thumbs up to Chinese scientists. Like Professor Li said, we could analyze the bubbles in the ice cores. As our viewers can see, with the heat increase, the ice will melt. Then it transforms into water. What water can tell us? And then let's take you to learn something about the water composition and Professor Chu will introduce to us how to analyze the water content in the ice cores. Good afternoon, dear viewers. In the lab, I'm responsible for equipment maintenance. I'm an engineer. Just now we've learned something about it. But water can contain almost everything. With the rainfall falling down onto the earth, it transforms into ice, but after all, it's composed of water. So we have to study the water content. This is the ion chromatography. There are 8 ions in the water. They are relevant to our lives. For example, if you buy a bottle of mineral water like 农夫山泉, you may have overlooked the contents of the 8 ions in that mineral water. Just now, the room we entered was open, but this one is closed. Why? Because we have to analyze the ions in the ice core. And the content of ions in ice core is very small. We don't want them to escape when we are analyzing it. Then there will be errors. The bottles we use might be polluted, so we need such a purified equipment. This is the most advanced purifier in the world. It produces different water from the drinking water. There is no ion contained in the water produced from this equipment. The total ion content in the water is less than 1 ppb. There is only water molecule in this water. It's pure water. After all, in the ice core, the content of the ions is very, very small and it's almost neglectable. So we have to guarantee the purity of water. You cannot use the water like the drinking water. So we have to wash even your bottles with this pure water produced from this equipment to guarantee that everything in this laboratory is not polluted. And this is our refrigerator. There are a lot of refrigerators in this room because throughout the year, we have been analyzing the contents of ions in the ice core. We will finish the entire actions very quickly. So on the opposite side of the equipment is refrigerator. We have to act quickly. They have been put into the sample bottles because they have been analyzed already. If not, we will put them here in this bag. It's for public use. This refrigerator is for public use. As you can see, this is about 1/4 of the ice core. It's round in shape from this angle. And you can see the bubbles. If we analyze the ions, we have to keep cutting it. And usually we will wear the gloves to cut it. For the outer layer of the ice cubes, we will do some other experiment with less stringent requirement, and we will analyze the ion with the center ice. There are 8 ions. And that's for testing the content of ions in the ice core. The next stop is an open space. We will inform you about what other analysis we can do with the water. We will analyze the isotope in the ice core's water. That's the most important information we can distill from the wordless scripture. I got a helper. This is our tool. We drink water every day. You don't take it seriously. But we may be drinking different water because the isotopes differ. Usually the molecular content is 18 with oxygen and hydrogen. But there are two other molecules in the water with very low contents. Even very small in content, they are the focal point of the scientists' studies. That two molecules tell us a lot. With our instrument, we could analyze the samples. And for the understanding of our viewers, I have covered this graph because it's too complicated. Let's directly look at these photos. From the outer layer of the ice cores, we will melt it about 1 hour before, and then we put them in the equipment. Those are the waves, and the scientists can interpret those waves. They could get the temperature information from the ice core. Let's get back to this equipment. It's for testing the isotopes in ice core. It's moving. It's like a robot. This is the mechanical arm. It's fetching water. We have been injected. It looks the same as that injection tube in the hospital. We distill the water from the ice cubes. It's highly efficient. Once it's informed that the preliminary processes have been done, it will start the scanning. And this is the chromatography results. This is the log. It's been preparing for the distilling of the water in the ice cubes. It will start moving once it got the alert. Last time we do the live show, it didn't move. That's because between two movements, the time difference is about 9 minutes. It will wait for 9 minutes before it restarts. It will analyze the molecular composition in the water. Still, it's very small. It's ppm level. But it decides the difference of different water, and it interprets about the rainfalls in different years and other climate information even thousands of years ago, because those information have been kept in those ice cores. It's very complicated. It has to go through correction to get the final result. So this is about the isotope information. We are lucky because this mechanical arm is moving. Now it's taking in the sample. The temperature is about 110 Celsius degrees. It's above the boiling point, which means when the sample is tested, the water molecule is in the form of gases. It's been gasified because of the high temperature, and then we get the results about the isotopes. You might wonder, in this sample box, there are different colors. Water is put in this 2 ml bottle, and the red caps are samples, standard samples. The results are data and figures. They are relative, in relative terms. And the red bottles are like the baselines. The isotopes in the water of ice cubes are small in content. it requires higher accuracy. In the isotope area, we could trace back how to guarantee accuracy. We buy IAE. The isotope samples are sold one time in a year from IAE. This is the second part I want to introduce. Isotope standardized water. That's what we bought, and on the right side, that's what we made. We have to use such sample every day. After purifying and other processes, we can also make such standardized water, but still you cannot guarantee the accuracy. IAE will encourage all the laboratories in the world doing the isotope work to work together. They will offer some blind samples. Those blind samples will give you a scope for your making of those standardized water. Because of the epidemic, there was supposed to be some blind samples in March, but it was postponed. This is my name. This is my ID sent by IAE. This is the result of the ID. And that's the data. And that's the score. It's excellent. So all of the dots have been the results from 200 laboratories. That vertical line is about errors, and that horizontal line is 0. This is oxygen 18. So the error is very small. For example, this laboratory will have to check what mistakes have been made because the error is relatively higher. What's the conclusion? Scientists from our laboratory have published a lot of papers. Like Professor Chu said, we made a lot of efforts to distill the water of ice core into that mechanical arm, and we did a lot more to analyze the data. From 4 ice cores from Tibet, we analyzed the changes of isotope in the past 2,000 years. The red color represents the warm years, and the blue represents the cooler years. In the past 200 years, all of the ice cores showed that they have been stored in a relatively higher temperature. But of course, over the past years, there have been some fluctuations. In comparison, in the recent 200 years, they're mostly in red color, which means in the past 200 years, mankind experienced global warming. So it's very clear information. The globe is warming up. From the ice cores, we know what happened 2,000 years ago. But will the entire history be analyzed with just the ice core? Actually, no. We could only study the past thousands years ago. If you want to learn more about 1,000,000 years ago, we have other instruments and equipment, and that is about the lake sediment core. So we will invite Professor Gao to introduce to you. Good afternoon, ladies and gentlemen. My name is Gao Chaopeng. I'm another researcher from the Key Lab. Just now, you've heard a lot about the ice cores. On my turns, I will introduce to you about the lake sediment cores. So the first topic is ice core, and now we will turn to the lake cores, which will inform us about even 1,000,000 years ago. What is the lake core? Where does it come from? Our scientists have been drilling on top of the lake. We have to build a platform and there is a drill. We tuck such one pipeline into the bottom of the lake. And you could see the sediments, the mud, in the bottom of the lake. It's just the lake sediments. Every year, the particles of the atmosphere have been falling layer by layer into the bottom of the lake. So those sediment carries the climate information. That's why the lake sediment cores may interpret the climate information. It's the sediments year after year, just like the ice cores. They are layer after layer, like the pages of a book. The difference is that for the ice cores, it's from snowfalls, but for the lake cores, they have been piled up from the air. It's like the nature is writing a book, page by page. So it's a really good metaphor to call it a wordless scripture. This is the photo of the drilling. It's in very poor conditions. The platform is very small in space. If there is strong wind, it will be unsteady. The scientists work in poor conditions and they put a lot of efforts because it's dangerous. Like Professor Zhang said, in the ice cores, you have to climb to 5,000 or 6,000 meters high to distill the ice core. So we think this is a job for the brave people because it's dangerous and it's a tough job. Tibet is like the roof of the world. So for the researchers and scientists studying Tibet, they are representing the highest point of the science. Now let's get back to the lake core. Why are we studying the lake core in Tibet? Speaking of Tibet, you will think about Chumlama. In addition to that, Tibet is also home to a lot of water because of the glaciers. There have been a lot of big lakes and rivers like Yangtze River, Yellow River, Lancang River. They have their sources in Tibet. So it's called the Water Tower of Asia. That's another name of Tibetan Plateau. From this map about the lakes in China, southern China is not home to a lot of lakes. Instead, Tibet enjoys a lot of such lakes. So we study the lake sediment cores because it's mainly sited in Tibet. And also Tibet has more sediment environment, and the majority of those lakes have been in high latitude, and they haven't been frequented by mankind. They haven't been polluted. That's why we choose to study the lake cores in Tibetan Plateau. Now let's see the record of the environmental changes. The lake core is also the wordless book of the nature, but we need the page numbers. Otherwise, this book will be orderless. This equipment is to decide the page numbers of the lake core. This is the particles of the lake core. This tank is to test the activity of radiology. Don't worry, it will not hurt human beings. It's not to prevent the release of the radioactive activity, and it's very mild. After all, even in the atmosphere, there have been some radiation. If you pay attention, in the air pollutants, there is one such pollutant. It's radioactive. From U238 to the other processes, there have been a lot of atmospheric change. It's chemical knowledge. Most of the intermediaries are in black color. Only that one pollutant in the atmosphere is in gas condition. So they have been released into the atmosphere we breathe in. When we do the indoor decoration, we don't recommend you to use that pollutant because it's radioactive. What's its relation with lake core? The half-life period is very small. Together with the atmosphere's sediment, it will fall into the bottom of the lake. And gradually, it will decay into zero, together with the half-life period. And then we can get the information about the years. After 7 half-life periods, it's difficult to test with the equipment. So with 7 to 10 equipment, we can only decide about 150 years. You might wonder, you just now told us that the lake core could tell information about tens of thousands of years ago. That has to be decided by the isotopes. The organisms are actually interacting with the air, particularly after the animals die. There will be a deterioration process. Then, we can study about 40 to 50,000 years ago. Now the pages have been put on the book, but there have to be some contents. Now let's keep moving. This is another closed room. It's a scanner to scan the lake core, their samples. To avoid the water contents to escape and to prevent pollution, we wrap them up with the plastic films. The entire process of studying lake cores is very complicated. We have to slice it to about 1 centimeter or even 0.5 centimeter. Now with this equipment, everything is simplified. All we need to do is to put this sample into the left side of this equipment. Then we can get like the physical examination result of the lake core. This entire process is like the examination process of the lake core. What's the story about the lake and the glacier? This is called Qinghai Lake. Glaciers and lakes are very close together. What's their story over the years from this first map? The light colors might be the materials brought by the glacier melting. We cannot get more information from the light color. From the perspective drawing, when the density is higher, it looks darker. In the light color area, the density is smaller. Can we say that when the glacier is melting, there will be a lot of big particles in the sediments, and in between those particles, there will be some pores and space, explaining the light color. That equipment is called fluorescent scanner. There will be fluorescent light from the sediments, and we can analyze the elements in that color. When the glacier is moving, there will be some production of the elements. Glaciers move slowly. And it's reducing time after time. That implies global warming. So glaciers and lake cores have been interacting with each other. When it's cold in temperature, the glaciers will move on, and the lake core will take a step back, and vice versa. Now, with global warming, the academia have been worrying about the glaciers. Maybe one day the glaciers will keep melting and do not interact with the lake anymore. That's a sad story. So we have to call upon environmental protection. So that day will come later. We hope that the lakes and glaciers will work together forever. Imagine that one day the glaciers keep melting and vanish from the globe. What will be the result? Professor Zhang will interpret. According to many studies, people have been worried about the vanishing of the glaciers from this globe. Some of the smaller glaciers did vanish from the Tibetan Plateau, but according to the study, 60% of those glaciers will remain here with us by the end of this century. What we truly need to pay attention is about the speed of the extinguishing of those glaciers. In addition to ice core and lake cores, we have to study future and the modern times. So Professor Gao, could you introduce more? Actually, my part is done. Okay, so from those different sorts of instruments, we have introduced a lot of ice core and lake core. And how could those two cores tell us information about thousands of years ago in Tibetan Plateau? Our scientists interpret the wordless scripture here in this laboratory. They have put down the page numbers in the nature's book, and they also interpret the words in that scripture, so we can know the changes in the climate situation in Tibet. Now let's have a glimpse of the result of the researches. A little reminder here. This laboratory has been in usual conditions. All of the scientists and the instruments are still working. Only a small part of the instruments are turned off. So that's why in the live show we could hear the buzzing sound of those instruments, because we are showing you the real situation of those scientists in their laboratory. Finally, let's have a look at the outside of this laboratory. This one wall. Through analyzing the ice core and lake core, we have published a lot of papers. With those papers, we could write down the nature's information for the understanding of the public. I want to introduce to you that in 2017, Mr. Yao Shandong, our academician, won Weijia Award. This award was launched in 1881, and about 60 scientists have been awarded. And Professor and academician Yao studied climate change and the glacier changes. He was the first Chinese to be awarded. So our team of scientists could earn high awards by just studying the muds in the lake and such a small slice of ice. With that researches, we know how to react to the climate change in the future, and we do hope that the Tibetan Plateau will have better environment and the world we live in will be in a better situation. That's the information we want to spread out. Now let's zoom in to have a glimpse of those papers. They're all the achievements made by the lab's scientists. So many scientists and researchers have been working industriously. Those papers are just like their achievements and their medals. So today, with 4 experts from the Key Lab, we have done some profound interactions. We hope that with this 1-hour live show, you could have a brief understanding about how the scientists have been working on a daily basis and learn something about ice core and lake core. In such a forum, we know that so many scientists and researchers have been doing such scientific work. Like our experts have been highlighting time after time, we have to protect our environment so the glaciers will melt more slowly. We want to give our thanks to all of those experts for giving us so many information. And of course, our experts prepared a bonus. It's a gift. It's a very thick book. It's called Hi, I'm China. There is one media name online, and it's published. This book. There are a lot of beautiful photos and information about China. It's very thick and it's heavy. I heard that there will be a lottery process. There are 2 such books prepared to be sent to our viewers. You could pay attention to the sign-up block of this live show and leave your comments. Then the scientists will send you the 2 books. It's so beautiful. This photo is about 1 meter wide. It's also taken from Tibet. It's something to read and something to collect. So 2 books are getting ready. Those are the gifts prepared by the scientists and researchers. Thank you again for taking 1 hour for us to visit your workstations, and thank you for your time for interpreting. I also want to thank our viewers for staying with us. In the future, we will keep working with Chinese Academy of Sciences to bring our viewers more scientific knowledge. So thank you again, our experts, and also thank you, Chinese Academy of Science.